Hey Earth Science, Cody here, and today I want to talk to you about black holes. Now first, what is a black hole? Well, a black hole is a point in space where the gravitational field is so intense that no matter or radiation can get out of it. But mathematically speaking, black holes don't only form from stars. Of course, that's where we see them out in space. They form because stars are dying, but really, anything can form a black hole. This is due to something called the Schwarzschild radius. You, me, those turtles over there in the front of the class, anything can turn into a black hole if it is condensed into a small enough point where its density is so great that nothing can escape from it. You see, that's not really going to happen, obviously. You don't see things around in the world just turning into black holes. But take the Earth, for example. If the Earth was shrunk into about the size of a peanut, it would form a black hole. Now, fortunately for us, there's no known way to condense the Earth into the size of a peanut. But a star, much more massive than the size of our own sun, has a much bigger Schwarzschild radius, and the expanding gases that balances out the core's gravity is depleted, then the core collapses into an infinitely small point known as a singularity. But what is a point of singularity, and how do scientists know it's there? Well, we're going to get into that, but first let's talk about the three major parts of a black hole. The first part is called the photon sphere. Now this is a weird point in space where photons of light don't necessarily get sucked into the black hole, but don't leave it either. Instead, they orbit around the black hole. Now theoretically, if you were to look to the side, you would see into the past, and you would also see the back of your own head. As we move closer and closer to the black hole, we would eventually come to a point known as the event horizon. Now this is the point of the black hole where, once crossed, there's no going back. No type of light or radiation is able to escape from the black hole, and neither can we, so eventually we would come to our certain death. But how exactly would we die? Would we be crushed or compressed, like a soda can against cement? Actually, the opposite. You see, as we move closer and closer to that point of singularity, the gravity difference between our feet and our head is so much greater that we'd undergo a process known by physicists as spaghettification. Okay, so we've gone past the event horizon and we're approaching the point of singularity. Now what? What is the point of singularity? Well, honestly, it's just a fancy term for what scientists don't really know what happens. Because light doesn't escape from the event horizon, so we don't know what happens at the point of singularity. There could be a big ball of just condensed matter, or there could be a whole nother universe. There even might be something known as a wormhole, which doesn't necessarily break the laws of physics, and it could also be used as a way to time travel across the universe.
There are many theories for what happens to the matter that gets sucked inside of a black hole. One of those theories is the white hole. Most simply explained, a white hole is the opposite of a black hole. The matter that gets sucked into a black hole comes out the other end through the white hole. As a star collapses, the star becomes smaller and smaller. It becomes an incredibly dense speck called a singularity. As a singularity bends space around it to form the black hole, sometimes the core of the star continues to spin. So as the star continues to collapse, the speed of the core will increase and form a donut shape. Instead of space being wrapped around a single point, it wraps around the newly formed ring. This ring is believed to punch a hole through the fabric of space and create a tunnel. This tunnel is called a wormhole. Some believe that this tunnel can open up into a different or even a parallel universe. The wormhole ends in a white hole. The white hole releases all the matter which is sucked into a black hole. White holes, however, are still purely theoretical, and there is no observable evidence to prove them. However, the existence of a white hole has been mathematically proven.
Black holes are a possible byproduct of the death of a massive star, many times the mass of the Sun. In order for a star to eventually transform into a black hole, it has to be the largest of all the massive stars. Otherwise, it will just form into a neutron star, or if it is smaller, a white dwarf. This means that our Sun, which is a medium-sized star, will never turn into a supernova or a black hole, or neutron star. Rather, our Sun will eventually turn into a white dwarf. The life and death sequence of a star that will transform into a black hole takes the following steps. First, it transforms from a protostar into a main sequence star. Next, it turns into a red supergiant. After this, a supernova forms, spreading a sphere of light and energy into the space around it. This supernova is formed as the amount of nuclear thermal energy helping expand the star diminishes, and the gravity of the star causes it to collapse and then rapidly expand into this explosion we call a supernova. If the star was big enough, this supernova will form into what we call a black hole, which is so massive and has such a high gravitational pull that nothing in its vicinity can escape its pull.
Black holes are a relatively new finding in the scientific community, and a lot of research is still being done on them. So let's just hope we don't see any rogue black holes coming close to our solar system, or else we're all in really big trouble. Now, as always, thanks for watching.